excited to tell you all about Docker and Devcontainers. Now, I've already gotten a fantastic introduction from Serdes, but maybe some of you are still wondering, why are we talking about Docker at a Rails conference? And the reason is that Rails introduced Devcontainer support in 7.2, which means that now you can run bin Rails G Devcontainer on an existing project, or you can pass the Devcontainer flag when you are running or creating a new Rails app, and it will create these 3 files. These 3 files, when correctly configured, are all you need to work with Devcontainers in your Rails project. However, there's a couple of unanswered questions here, such as, what are these files? What do they do? And why do I even want Devcontainers? Let's start with that last question. So Devcontainers give you the experience of local development with the portability of Docker. Now, theoretically, you're getting the experience of local development by doing local development. So that makes the question, why do I care about the portability of Docker? There's a couple of reasons. First of which, it's really easy to onboard when you're using Docker. You're no longer looking through documentation or running scripts, which often run differently on different operating systems. The next reason is that you have a consistent dev environment. Everybody is working from the same Docker image, which means they have a consistent environment when they're working. Also, you can support Windows computers. You can use code spaces. So code spaces is GitHub's solution that allows you to actually run your development environment from a browser and through the cloud. Also, it allows you to isolate your environment, different Ruby versions on your system, different VS Code extensions, different libraries. All of that can be isolated so that your different development environments aren't interacting with each other or with your local system. This is particularly important in the age of AI, because this allows us to isolate those overexcited AI agents so they cannot access anything on your normal system. The other thing that's kind of interesting and exciting is that it gives you disposable environments. Oftentimes migrating from one developer setup to another, or when there are changes that need to be made, that migration is a completely different process from setting up your environment new for the first time. With disposable developer environments, you can actually throw away your environment and you can start from fresh. This fresh start is particularly important if you're someone like me who sometimes runs into these complicated, challenging issues that no one can help me debug. And when that happens, I take the entire thing, throw it away, and I get to start from a clean slate. I want to get a little bit more practical with this, though. I can click one button, and I can have RubyEvents running in the cloud because of Devcontainers. This right here is the button. This is RubyEvents running in the cloud. In my browser, Opera, I can run my tests. I can run my actual dev server and see it running. I can access all of my files, everything that I need to do in my browser. And if you look right there, that little yellow one, that's the slides for this talk. So that's proof this is my browser. All right. So I am an avid open source contributor. I have contributed to all of these different projects, and they all have different Ruby versions. They all have different libraries, some of them Postgres, some of them ImageMagick. I want to keep all of these separated. I don't want these environments clashing and affecting each other, and all of the migrations and changes and upgrades. Like right now, Lobsters is going through the process of moving from MariaDB to SQLite, and RubyEvents went from Melee search to SQLite search to TypeSense. If I step away from a project for a year and I try to come back, I really need a clean setup to work with, and I need to be able to toss it away. And I haven't even told you the worst part. I'm the person who uses Windows. And as an open source contributor, I can't sit with the maintainer for an hour to debug my setup. I don't know if you've experienced that when onboarding with a company where you have to literally sit with somebody who works in DevOps to try and figure out how to get everything set up. But Docker helps to solve that problem. What I really need is an isolated developer environment that can set itself up and be tossed when I'm done with it. That is the reason that I am really glad that Rails introduced Devcontainers in 7.2, because that means that we can all congregate around an isolated containerized push-button dev setup. Before we get into what these files are and what they do, we really need to talk about Docker. So Docker was a solution to a different problem. Deployments were fragile. Deploying meant SSHing into a server, copying files over, running scripts, hoping that you didn't miss a step or mutate the environment in some subtle, irreversible way. Docker changed that. What Docker did is it built an image of a computer, and it could run it in any container, which means that if you could build an image of your server, then that deployment would succeed. Now let's define those terms. So an image is a snapshot of a computer at a moment in time. It's going to hold your dependencies in your files. It's going to contain the OS, but it does not execute. It is static. A container is loaded with an image, and it runs a command. So it starts when the command does, and then it stops when the command ends. Containers can run on different operating systems because you've installed an OS-specific Docker tool or something else that understands how to start a container on your operating system. Now I feel like we're ready to talk about these files. We're going to start with the Docker file. So the Docker file is a set of instructions to build an image. And what we're going to do is we're going to go through a bare bones, simple example of one. So we're going to start with a from. For our Ruby projects, this is normally Ruby and then the version. This Ruby image is what we're starting with. This Ruby image is actually built from a Docker file itself. So it's going to start with a version of an operating system, Alpine, Bookworm, Trixie, and then it's going to run a series of commands, and then that Docker file will be used to build the image that we are using at the beginning of ours that has Ruby installed. Let's go back to our simple example. So our next line is workdir. This is going to set the directory that we're modifying and that we're adding changes to and running commands from. Next, we're going to look at the run command. In this case, it's going to call the command gem install bundler for us. Our next one is copy here. So this is going to copy files from the context of the Docker file, basically the place it's being run from. So this is your local system, and it's going to copy it into the folder that's specified there. This is a little bit tricky sometimes because all files are going to be in the destination folder. So if you call something like copy./bin setup, that's going to get copied over as setup itself. We're going to skip over our good friend run again with bundle install to get to command. This is kind of the last most important command that we're going to discuss. As I mentioned before, when you start a container, it starts up, it runs this command, and then it shuts down when that command has completed its session. In Docker's deployment days, this was normally the server command, like bin server, whatever it is that you needed to run, and we often see that reflected in Docker files today. This command frequently gets overwritten by the Docker CLI, by Docker Compose, and by the devcontainer.json, as we'll see as we go through. This is really important, so we're going to review it. The Docker file is a set of instructions to build an image. This is how you actually build that image. So you're going to call Docker build. You're going to call the name of it, which is that -t. The -f is the Docker file that I'm using, and I said it copies files from your system. That's why you need to specify the context that you're calling it from, which in this case is dot. Now, let's talk about this image that we've built. This image that we've built is what ends up getting run on the container. So let's talk about containers. I want to review them, and then we're going to add 2 new concepts. So containers, it's loaded with an image, and it actually executes the command. It starts when the command does, it stops when the command ends. Containers can run on different operating systems. And this is our new concept. Containers can have volumes and bind mounts attached. So a volume, basically those containers, they spin up, they run the command, they shut down. That means the data that's created on them is impermanent. Volumes allow you to store data outside of your container. So this is typically where your database data goes, and these are managed by Docker, so it's not visible on your file system, and you would see it inside Docker. The other type is a bind mount. So bind mounts are a type of volume that are read-write. The changes between your file system and the file system inside Docker are synchronized, and your bind mount is managed by you, and you should see the files in your file system. This is typically where your code goes because you want to keep it synchronized. This is really abstract, and it's a little bit hard to understand. So I want to make things a bit more concrete for you. We're going to run tests and bundle install using just a Docker file in the Docker CLI. We're going to use a real-life example from RubyEvents.org. So you can actually, this is a production, live, open source app. You can clone it, and you can run any of the commands that I mentioned or that I call here, and it'll give you the same results that I described to you here. So let's go ahead and run tests and bundle install in Docker. So this is how you run tests using just a Docker file in the Docker CLI. First, we need to build the image. Then, what we need to do is call this command every single time we run tests. So we're going to start with Docker run. That tells me go to the Docker CLI, run this command on a brand new container. Next, --rm. So I'm going to run it on a brand new container, which means every time I run tests, it's going to make a new container. This --rm says delete the container when you're done running it. -it, if I have a binding.irb, I want to interact with it. That's why it's it. Next, this whole thing is that bind mount, so I'm using the code that's on my system, and I'm including it in here. This is an example of how to build a normal mount. In our case, we're bringing in node modules, but this is the volume. This is the name of the image that I'm going to call this on. Then this is the command that I'm overwriting. I mentioned before, the Docker files command is commonly overwritten, and here's where we're doing that. OK. That's how you run tests in Docker. Yay! And the best part is these don't even succeed all of the time because they don't have access to type sense. Could add that, but it'd be even worse. OK, so based on that, you might have an idea for how you would run bundle install, which is the second thing we're doing. But this one actually fails too. The reason being that what I am doing is I am running bundle install on the container. But as I mentioned before, we lose all the data in the container, right? That means that your gems are not going to be installed the next time you try to run tests in the container. So this is how you actually do it. We do our Docker run, as you would expect, in order to add the gem and get the new lock file. And then we completely rebuild the image. This is actually kind of important. When you're looking at Docker, Docker Compose, and you're living in that world, any sort of new Ruby version, any sort of library changes and gems involve rebuilding the image. OK, the Docker file gave us consistency. All of the things that I listed in why Docker, a disposable environment, isolated, your agents can't go everywhere, all of those benefits, we now have access to them. But it is clearly unpleasant to use. That is where our next file comes into play. So the next one we're going to look at is devcontainer compose, or devcontainer/compose.yaml. This is your Docker compose file. So when it was running in production and it was being run by a script, Docker was fine, but engineers quickly started using the consistency of Docker in other environments, for example, dev setups. And the repetitive setup, passing the bind mount, all of that sort of stuff, very quickly gets grating. In addition, we needed multiple containers. Like, we need type sense in order to run tests. A lot of you will probably need to run your database like Postgres. Docker Compose lets you skip repetitive setup. So we're going to look at an example. This is the example that is generated by bin rails g whenever you generate a dev container file. So this is going to be the compose file from that. First, we're going to give it a name. That just gives it a nice little folder inside of Docker when you're looking at it. Next, we're going to list all of the services that I may need access to. So there's two types of services. This first one is going to involve building from a Docker file. So sometimes we call this Rails, web app, all sorts of different things. But this is essentially what we're going to build based on that Docker file. So first, we're going to say, I want to build this from the context of the parent directory. I mentioned we're copying files from a context. This one is inside the dev container folder. So what I need to do is I need to go up a level in order to access my gem file lock, and those other commands. I also need to specify which Docker file I'm going to use in order to build this. This is the volume definition. So in this case, this is the bind mount so that I can load in the files that I have locally into my container and use it. This is the command. So what I'm doing is I'm overwriting the command that's present in the Docker file with this one from the Docker Compose. Next, these are other services that this depends on. In this case, it's Selenium and Redis. Now we're going to talk about a different type of service. So this is our Selenium service, and it's much simpler than the previous one. So Selenium is an image, or Selenium standalone Chrome is an image that has been published by Selenium that you can use, and then we just need to say restart unless stopped. What this is going to do is it's going to restart this container every time until I manually stop it. Here's another one. This is Redis. This one would be published by Valkey. We have that restart unless stopped. And then here what we're doing is we're defining a volume. So this is going to store the data from Redis. It's going to use that data folder. And then the last thing that we do is we define and name the volumes that we will be using throughout the Docker Compose file and between all of our services. You really want to name these here because otherwise Docker will just give it an incomprehensible gibberish name. All right. So I said that this was going to make it easier. Let's use our previous example. We're going to use RubyEvents as files again, and we're going to run tests and bundle install. Da-na-na-na! So this is how we run tests when we're using Docker Compose. We have Docker Compose, and then here we're specifying the file. If you have your Docker Compose file at root and named appropriately, you don't need to specify this, but in our case we do because it's in that dev container folder. Next, we remember from the Docker command that we had this run --rm. We're bringing that back over. Last, this is the name of the service that we're using within the Docker Compose file. And then this is the command that we are overwriting it with. So let's do a comparison. These will both do exactly the same thing. Docker Compose is still long. I know there's a temptation to alias it, to put it in a script and that. But this is much easier to use than Docker was originally. And because it has type sense, the tests actually pass this time. In addition, Docker Compose understands that if an image has been defined and it does not exist, that it needs to go ahead and build that image in order to do it. So we don't need this first line here with the docker build -t. Now let's move on to bundle install. So this one's very similar in that it's much shorter, but if y'all were paying attention the first time around, this one also doesn't work. So this one is going to run on the actual container, which isn't going to save our gems into the image, which means that I won't have access to them on subsequent runs. So this is what it actually looks like to make that change. You would say docker compose -f, your file, and then you would say --build in order to rebuild your image. So on RubyEvents, some of this is the seeds, but running this command takes 116.8 seconds. Not fast, not quite enough time to make yourself a little cup of coffee. So let's talk about this. Docker Compose is convenient and it coordinates services. It doesn't fix any of the underlying issues with Docker though. That's where our last file comes in. This is the devcontainer.json file. Okay, dev containers are really cool and really interesting because they stemmed from a very simple idea, which is, what if we open the editor inside the container? And this enables so many things that aren't possible when you're using Docker and Docker Compose. So if you're using Docker and Docker Compose, you cannot run a lot of these VS Code extensions because your editor is in an environment where Ruby and these gems are not installed. Ruby and your gems are installed inside the container. However, if you move your editor inside the container, all of a sudden, all of these VS Code extensions like RubyLSP, Herb, Standard RB, and Ruby Test Explorer start working. Now, you don't have to prefix commands with Docker, Docker Compose, etc. when you're using dev containers because you're already inside of that Docker container. You don't have to start up a container to bundle, install, or run tests so that 116.8 seconds goes away. It only matters that you're bundle installing. You can run it in code spaces on the cloud because this is the interface to doing that. And you get this nice one-button setup inside your editor. The idea is simple. Ruby is installed inside the Docker container, so open the editor there too. Let's look at a devcontainer.json. In this case, we're going to use the real-life file from RubyEvents and go through it. First, we're going to give it a name. This is what's displayed inside of VS Code. Next, these 3 lines are all about defining where we're going to open the editor and which service we're going to open it within. So we're starting with Docker Compose file. That's going to tell it the Docker Compose file to use. Then we're going to say the service inside the Docker Compose file that I want to pull from. And it's going to understand, because of that depends on in the Docker Compose, what it needs to start up in addition to your Rails container. And then I need to specify the folder that I'm going to be using. Our next section is override command true. I mentioned that we're overriding the command from the Docker file quite frequently. What this is going to do is it's going to override that command with sleep infinity. So it's really important that we use sleep infinity when we're working with dev containers, because our container is now our developer environment. We want to be able to shut down the server. We want to be able to run bundle install. We want to be able to reset the database without introducing any errors or issues, because when that container ends, or when the command running on the container ends, the container shuts down, which means that you would no longer have access to your editor. This is why it's pretty important that we use Sleep Infinity. You have your editor in there, so we just want to turn it on and leave it on. This also allows you to debug setup issues within your editor instead of trying to debug it outside of it and hopping in and out of the container. Our next section is going to be customizations. These are customizations for VS Code. So we have some settings here that allow you to edit your editor, so you can edit your Git commands using VS Code. These next one are the extensions that we recommend. I mentioned at the beginning that we want to be able to isolate some of those VS Code extensions. I don't know if you've ever had the experience where you're working in one project with Standard and you hop over to another one with Rubocop and Standard starts reformatting your files or perhaps prettier or something else. This allows you to actually isolate it for the individual project versus sharing it between all of them. This next section are going to be features. So we're adding Git, GitHub CLI, and SSHD. All of these features are related to allowing you to basically run Git commands from within the container, because now you're operating inside of it, and you're going to need these things installed if you want to get your code out of it. This last section, the ports attribute. So now you're running your dev server inside of the container, which means we really need to specify these ports and allow your local server to bind to your ports locally so that you can access localhost 3000 from outside the container. This last section is mounts. So what you can do is you can mount random files. In this case, I'm mounting SSH keys. This is theoretically unnecessary, but VS Code is supposed to take your SSH keys and mount them in automatically. That hasn't worked for me in the past, so that's why this line is here. OK, we're going to run tests, and we're going to bundle install, and we're going to do it within the world of dev containers. You just run it, OK? Because you're in a world where you have all your Ruby gems, you have Ruby, and you have everything else installed. You're not dealing with containers. You're not calling Docker Compose. Whoops. You just run your tests. And now we're going to talk about that bundle install that's been giving us issues in the past. You just run bundle install. It doesn't matter that the image hasn't been updated, because when you're working in a dev container, you're working in one container. You're not running tests on different containers, which means it's fine that this one container is the only one that has bundle install. And if you run into issues, again, you can delete the Docker image, you can delete the container, and it'll rebuild it. All of this stuff is possible because we had this idea, what if we just open the editor inside the container? And now we finally have the missing puzzle piece for dealing with Docker and Docker Compose. Dev containers give you the experience of local development with the portability of Docker. So let's talk about why we cared about Docker in the first place. You have easy onboarding. You have this consistent developer environment for everybody. You have Windows support. You have code spaces support. You can isolate your environments. You can isolate them from those overexcited AI agents. And you can even have disposable environments, so if you run into issues, you can just throw the whole thing away and start fresh. But no technology is perfect. So let's talk about what Docker didn't give us. I've been using a very specific word here, consistent. Consistent is not the same as good. Your first dev container will kind of suck. Maybe it'll have too many layers, memory hog, maybe it'll have missing packages. But because it is consistent, people will go through, they will work on it, and they will improve it. And eventually, your new hire will push one button and get the exact same developer experience as your most experienced engineer. One of the things that I've noticed is that we're willing to let humans struggle with documentation and set up scripts and say, you're using a Linux box, that's your problem. But we don't let the robots struggle, mostly because they can't. We fix things when it's automated. And that's the case with Docker as well. Let's talk about some other things, like what if I don't use Docker or VS Code? So if you don't use Docker, that's actually okay, because it works in code spaces, like I said. It works in Windows Subsystem for Linux. It works in Kalima. It works in OrbStack. I've only checked the first one of these, but Rachael says it's true, and I trust him. He did a talk about the frontiers of developer productivity in Rails at Rails World. I recommend it. And then, what if you don't use VS Code? Because I imagine there's quite a few of you in that bucket. It works with IntelliJ. It works with Vim. It works with Emacs. It works with Cursor. Again, according to Rachael, I haven't actually tested this. And then our last question here, hopefully at this point you're asking, okay, maybe I want to build a dev container. And if that's the case, I have a couple of different resources for you. So first of all is that talk from Rachael. Next, we have the edge guides from Ruby on Rails on getting started with a dev container. Because they've built support into Rails, there is a Rails guide on how to set up a dev container. There's also the Docker guides in containers.dev. Evil Martians have done one about Ruby on Rails that describes like a very complicated, sophisticated setup. So if you run into any issues, that might be a place to look at. And last but not least, there is a companion blog post that was published just yesterday that describes everything that I've talked about in here on my blog site. Okay. I hope that all of you go off and run binRailsG dev container, and I hope you make one that sucks. And I hope eventually it gets better. Obrigada.